Hello everyone, today we are going to solve the problem sorted array search. So in this problem, they give a array which is in the ascending order by default and an integer k. So our task is to find if the integer k they give is present in the given array or not. So if it is present, the output should be true, and if it is not present, the output should be false. That's it, simple. So if you see the first example, we can see the given array is 1, 2, 3, 4, 6, and the target value is k equal to 6. So if you see in this array, as it is in the ascending order, we can find that k is present in the array. So what is the output? It is true, like this. So if this is a given array and the k value is 3, we can see 3 is not present in this array. So output is false. So in this way we need to manage the input and output and process the output. So the constraints are, as usual, the array size is minimum 1 and the k value also minimum 1, and each and every element value is also minimum 1, max 10 to the power of 6. And if you see this, the expected complexities, the time complexity, it is big O of log n. So by this what we can see, if it is a normal array search, we would take around big O of n time complexity, in which there is no order like ascending order, descending order. But in this question, they specifically mentioned sorted array. So for this type of questions, for the sorted arrays searching, we have a specific method or a technique which is binary search, which optimizes the search technique for the sorted arrays. So its time complexity is also log n. So they indirectly mentioned to us that to use binary search for this question. By this we can say that. So space is big of 1, means some variables constant space. So what is binary search? It is a divide and conquer approach to solve a problem. So in this, we keep on divide the problem until we get to a state, and then we will use those blocks and conquer them to find the answer for that question. So in this binary search, we use to divide the array, we use a mid value as a dividing parameter. So how it is done? So if you see this in example, we will demonstrate it using this example. So the array is 1, 2, 3, 4, 6. So the length of array is 1, 2, 3, 4, 6. It is 5, and the k is equals to 6. So we need to find 6 in this array using divide and conquer or the binary search technique. So how? So there are some sequence of steps which are applied continuously to find the answer. So let us take step 1. So before that, we use two variables, L comma right. L means the leftmost index at the initial position, it is 0, and R is the rightmost index, which is 4. In this case 0, 1, 2, 3, 4, like that. So what we will do with this left and right two variables? So continually we apply the divide and conquer technique. So how? So for every time we make this, we find the mid value using the most basic is the left plus right whole divided by 2. This is the simplest one. Some optimized one is left plus right minus left by 2. So this is a basic one and this is the optimized one. It is preferred to use rather than this one. So left plus right minus left, this one only divided by 2 plus left value. So we don't use this one. So what? So for every iteration we find the mid value and check if the present at the mid index in a array. If it is a array searching problem, is our k value. If it is yes, then output is true. If it is not present, we have both ways to check if it is less or greater than. So value at mid is less than k. So what does it mean? So if you check, our k value is 6 and our mid value is 3. The value at mid is 3. So our value at mid is less than the k value as in this case. So what should we do? So we can see we should search this right of the array, the off array. So how can we do? So if we keep left here and right here at last, we are searching whole array. So if we need to search only this part of array, then we should move left or right. So we should move right left pointer to this point, the 3 or the mid value plus 1, so that for the next iteration we will be only searching this part rather than the whole part, because we are using the sorted nature of the array. So if it is less, then what we will do? We will modify the low pointer to the mid plus 1. Similar way, if value at mid index is greater than k, then if it is k value equal to 1, then what does it mean? Our mid value is 3 and the k value is 1. So we need to search this of the array. So the left will be as it is, but right will come to here, as we can see, to the mid minus 1. So the same changes we need to write in the code as it is. So what did we say? Right equal to mid minus 1. We adjust continuously this left and right pointer so that our searching space of the array or a subarray will go on gradually decrease, so that at some particular point we just reach only one particular element, so that is a k value or not. So to that point we will just go through these two conditions by decreasing the search space from the total array. So above all this, we will check if our left is greater than right. Then what does it mean? If the k value is, suppose let's say 7. So at last, first it will go here, then it will come to this off, it come to this off, and after this, any one of the pointer will be excluded from the actual length of finding the space. Means actually what is the meaning of left and the right? Right is always greater than left. As we can see here, if it is 0 and 4, right is greater than left. If suppose left is greater than right, then what does it mean? Invalid indexes are started to come in the iteration. So we should break from the loop, because if left greater than right, as we can see here, if it is a k value is 7, so we keep on searching using these three conditions, and we will go out of bounds from the array. So we need to break from the loop, because our searching process is over, completed, because we didn't find the k value. So like that. So these are the simple 4 steps or the 5 steps we will write in a continuous loop, and the loop condition is left greater than right until that one. So this is a simple 5 steps we use in the binary search to find any element, if it is present or not, in a sorted array. So we use two variables. Left begins with the first index, right begins at the last index, and keep on traversing like this. If it is left, right. Next step, left. Based on these conditions, the left and right pointer are modified. So in between anywhere this, if the value is true, means we found the element. So if this whole loop completes, then we didn't find the element. So what is the output? It is false. That's it. This is a simple way how we can search the value. So how to do it? As we can see, we already wrote here. We use two variables. So simply use the same things, 0, and here we took this example, but in the code we should take it dynamically, the length and the last index. So how we can we take right equal to, how can we get the last index of any array? Using the array dot length variable minus 1, because array indexing is 0 based, so it is always minus 1, the last index, then the length. See, for example, if the length of array is 5, the last index is 4, so 5 minus 1 is equal to 4. So like that. So next, as we can see, we will start a loop. So here we know the breaking condition rather than the number of iterations. So seeing the criteria and we have, we will use a while loop, because when you know the breaking condition like we have here, we will use while loop. But if you know the number of iteration perfectly to be performed, then we will use a for loop. So while left is not equal to right, means until our valid search process is continued, we will be in the loop. But whenever we get this condition, immediately we will exit from the loop. And we wrote 4 lines here. What should be right in this loop? So first of all, we calculate the mid value. Let us take it as mid equal to, what is the optimized way? Left plus right minus left by 2. So we can see there are 3 conditions here, the if conditions. So let us write one by one. So how we can write the if condition? If inside the brackets the condition, what is the condition? If value at mid is equal to our k value, then what it is say? We should return the which type of value? It is a boolean value, and the boolean value is true for true case. So like this. If this condition is not satisfied, then what we need to check? Value at mid less than k. So same right here. Value at mid is less than k. So what did I say? We need to search the right half of the array. So like this one, this half of the array, if it is the second condition. So the actual code part is left equal to mid plus 1. So using this we can search the process to the right of the array. So if this both conditions are not true, then obviously the third condition will be true for the left half of the array. For the condition value is at mid is greater than the k. So like this. So if this whole loop continues and it executes completely, but we still didn't find the k value. So what is the meaning of it? The k value is not present in the array. So in that case, what should be the output? It is false. So simply return false. So if you run it, so for the template execute it is passed. So we can see the problem is solved. So we used a constant space, more specifically just two variables, integer, which take a common space or a constant space for any type of input, independent of its size. So it is constant space. So for the time, if you go and draw a tree structure for this array manually to check, like splitting this array into two parts, like this and like this continuously, and then merge them, so we get a tree. And we know that the height of a tree for a number of n nodes is log n. So in that way we will get the log n time complexity. So this is how we can solve the problem sorted array search using a most popular technique called binary search, which you can see here what it is, and for example how we can solve manually using that technique. Solve or practice the program. Thank you for watching.